How's it going? Welcome to Algebra Prep Academy, and today's lesson is solving multi-step absolute value inequalities with graphing.
Here are some quick notes that you can use as a reference throughout this lesson. Our problem is negative 2x is less than or equal to 8. We divide both sides by negative 2, and this is a double negative. Because of the two negative signs, our signs will switch. So our answer here is x is greater than or equal to negative 4. We can graph this inequality like this. When graphing, an open dot is used when you refer to greater than or less than signs. Meanwhile, a closed dot is used when it's greater than or equal to, less than or equal to, or just plain equal. We have the inequalities x is greater than 3 and x is less than or equal to negative 2. The first inequality is graphed with an open dot and it faces right, while the second inequality is graphed with a closed dot because of the equal sign and it faces left. These two inequalities together are an OR statement, but we'll get to that in a bit. When we graph in the direction the arrow faces. So here, we graph with an open dot, and it faces right because that's the way the arrow points. These two inequalities are graphed with open dots, and they face in the direction that their signs point. Since these face opposite directions, as you can see here, this is an OR statement. Here we have the inequalities x is greater than or equal to negative 2 and x is less than or equal to 1. We graph these with closed dots and you'll see that they face each other. When they form one line segment, it's an AND statement. We then write the solution like this with the variable in the middle. Our first problem is the absolute value of x over 2 plus 3 is greater than 9. First, subtract 3 on both sides to isolate the absolute value. We then end up with the problem the absolute value of x over 2 is greater than 6. Then we branch this problem into two separate problems. One problem will be the same thing we have up there, while the other one will have the inequality switched and it'll be a negative 6. We'll solve the inequality on the left first. Multiply both sides by 2 to isolate the variable, and our answer is x is greater than 12. We do the other side the same way, and our answer is x is less than negative 12. Now we draw our graph, and we label both sides of the zero. Both inequalities are graphed with open dots, and because of their signs, they face opposite directions. This is an OR statement because of its opposite directions.
For our second problem, we have 4 times the absolute value of 4 minus x plus 6 greater than or equal to 30. Next, we have to subtract 6 from both sides of the inequality. We end up with the inequality of 4 times the absolute value of 4 minus x is greater than or equal to 24. Next, we divide both sides of the inequality by 4. This gives us the absolute value of 4 minus x is greater than or equal to 6.
We then branch out this problem to 4 minus x is less than or equal to negative 6. The other problem is 4 minus x is greater than or equal to 6. Here's a little recap of what we just did. One side stayed the same while the other side had its sign switched and became a negative 6. Subtract 4 from both sides to isolate the x. We then end up with the inequality negative 1x is greater than or equal to 2. Divide both sides by negative 1x, and because of the double negative, our signs change. So we have x is less than or equal to negative 2. Do the same thing on the other side. This is another double negative, so the signs switch and our answer is x is greater than or equal to 10. We graph both lines with closed dots, and they face opposite directions because of the way their signs face. Because they face opposite directions, this statement is an OR statement.
For our third problem, we have 12 is greater than or equal to the absolute value of x minus 8 minus 4. First, you add 4 to both sides to isolate the absolute value. The 4's cancel out, and our new problem is 16 is greater than or equal to the absolute value of x minus 8. When you have an inequality like this, it's nice to rewrite the inequality so x is on the left side. Our new equation is the absolute value of x minus 8 is less than or equal to 16. Since it's an absolute value, there can be two problems. X minus 8 is less than or equal to 16, and x minus 8 is greater than or equal to negative 16. Solve each inequality separately and add 8 to both sides. The 8's cancel out, and x is less than or equal to 24. Add 8 to both sides again. The 8's cancel out, and x is greater than or equal to negative 8. Now we graph our two inequalities. They are both closed dots since there's an equal sign in the inequality. Both lines are graphed in the direction the inequality is facing. Since they're pointed towards each other, it's an AND statement, which means that x is both greater than or equal to 8 and less than or equal to 24.
Thanks for watching! Please make sure to like